Okay, so here we will start our session today to talk about um, large language model for tabular data set. So welcome.
Hello, I'm Tawkir Saeed. It's first time joining this meeting. Happy to be here.
Yeah, welcome. If you wanna introduce yourself a little bit.
Oh, yes. I work for the IRCC in Ottawa, Immigration Refugee Citizenship, and as a data analyst. I'm interested in language models. I run local models on my own hardware, and I'm eager to learn more.
Oh, perfect, perfect. Welcome. So what made you interested in today's topic that you will find, maybe interesting?
Well, there's the problem of context with language models. And the way to go about circumventing that is one of the strategies is to use LangChain. So instead of having all the data inside the context, you can feed the data partially using LangChain, which isn't really the language model itself, but it basically pulls the relevant context pulls the relevant data into the context.
Perfect, perfect. Great that you gave a great introduction about the background of basically what is being the most popular way to leverage LLM so far. So in our previous sessions, we touched briefly upon what you just described. Mostly is on generating text, right? Like generating a question and answer type of problem. So, but as we know that most of the time, what we would encounter is actually a data set that is in a table format, like in an Excel sheet or CSV files, or even say in the relational database, like in SQL Server. Those type of data, they usually exist in a structured format, like having column features as well as rows. So we would be interested in actually how can we leverage large language model like ChatGPT also handle those type of data sets. So today we actually will touch two ways to deal with this type of tabular data. So as you can see on the screen so far, so we define the types of problem that involve tabular data will be first one, it will be a search engine type of problem. So in that sense, it will be basically query and answer questions about your table data. And then the second one, it's a more traditional typical type of classification problem. So as we know that in the most conventional, like machine learning problems, it will be like you have rows and columns and then you want to actually predict, right? So we know like such as the Titanic data set that is being hosted on Kaggle. They always say that's like a very good entry problem to a machine learning problem. So that type of problem, like you would have, say, different people say which part of the Titanic ship that you actually live in, and then also your age or gender or whatever, and that is to predict then the survival chance of you from that accident. So for example, then when you have those column features and you want to predict the outcome. So that is another.
The volume is a little loud for the music.
Oh, okay.
I can still speak.
Okay, yeah. Okay,
Sorry. Thank you.
Yeah. And then so then that is okay. So we'll give it. Need to lower down our voice. Okay, and then so that type of problem, then we will use our tabular data to predict. And then, so we will then just explore actually how ChatGPT or large language model would actually handle those type of prediction problems. So it's not just query and answer to search or to, in that sense, in the NLP problem, it would be to like extract data or say summarize data or generate data, but really it's actually a supervised classification problem. Like how do we actually use ChatGPT for that? So so firstly we will just touch upon how the first problem, right? For Q&A problem, so query and answer, so more like a chatbot, like a search engine. So for that one, LangChain is definitely a good useful tool, as our member mentioned here. So so we would then look at actually the key components of LangChain that can be used to solve this type of problem. So firstly, it would involve a tool which is called agents. So basically, three main important components. So the first one is agents. So agents is a large language model that is given an initial prompt to break down a complex query into a sequence of steps to resolve one problem at a time. Uh, so this is just like our typical, large language model, so which is called agents in this context. But in order to really solve this problem related to tabular data, it actually needs the help of experts. So the experts in this context will be presented in the format of they call it ChatGPT plugins. So what the two most popular uh, expert system to help to solve tabular data are, one is called Miracle system. So it's MRKL. It's pronounced as miracle. So this system combines large language model with external knowledge sources and discrete reasoning. And the second system is that is to help to solve this problem is called React system. So this system actually synergize reasoning and acting. So together you have one agent, which is the main large language model, together with two helper tools, which is Miracle. The other one is React. So we will then take a look actually how you would implement this workflow in LangChain to build build a search engine or Q&A engine for tabular data set. So this one, you can actually refer to Azure samples on the Azure GitHub. So you're welcome to explore there's examples there. So the first step is you need to create this agent, right? So this agent, you use the so these are actually all in the library of LangChain. So you create the pandas data frame agent, right? Because we know that pandas data frame are all in the format of a tabular data set. So it has three parameters. So the first parameter, you need to specify the large language model you're using. And then the second parameter is the tabular data set that you're querying about. And then the third one is the verbose equals to true. So so this is so then after this step, then you actually construct agent, which you basically already involve the large language model here, right? So then the second step, then you would start querying your tabular data set. So here, like basically the most important step to query about ChatGPT is actually the prompt, right? To construct the prompt. So here you actually have three components to construct this prompt. So here you will see that you would have firstly a prompt prefix, and then the middle part is actually the real question that you're querying the ChatGPT model. And then the last part is you need to also add a prompt suffix. So maybe we can maybe explore actually what each of these three parts are doing, right? So for the prefix, so mostly prefix and suffix, they are actually statements to instruct the ChatGPT. So they're mostly instructions for the ChatGPT, but the middle part is actually the real questions that you're querying. So so the prefix to query ChatGPT is actually you're telling ChatGPT that you want you want the pandas data frame to show all the columns and the column names, as well as in this problem you're asking ChatGPT to answer your question, right? So the prefix you actually instruct three things. First things is to show all the columns. Second instruction is to get all the column names. And third part is to tell the GPT that it is to answer a question. Okay, so this is more like setting the context of the problem definition, right? Okay, and then you can query all kinds of things. So for say, if in the context of Titanic data set, then you can ask try to read, okay, how many people are there, right? Like, or for each of the cabinet, then, like roughly what is the average age or so on, right? So these can be your specific Q&A chatbot. And then the suffix of this prompt, right? So then you're giving it basically instructions on how ChatGPT should answer your question, right? And then, so prefix is to tell what, before asking the question, to tell GPT what what is the problem. And then the suffix is, okay, after you ask the questions, then you tell him in what format, right, that he should answer your question. So you should, in here you can say, you should try, like different methods, instead of just, one time and then you just give a final conclusion. So here it says, always before giving the final answer, try another method, right? And then to make sure that you're basically getting like an average smoothing results from different methods to before actually making the final answer, right? And then also it will say that do not make up an answer or use prior knowledge. Only use the result of the calculations you have done. So here, then it's basically a way to prevent as much as possible that the ChatGPT to hallucinate, right? We all know it has this tendency of hallucination. So you just add this one here. You can also see that for this so you actually, for the suffix, you actually listed them in the format of bullet points, right? And then also you can always use also the capital letters to emphasize the tone, right? Because I'm pretty sure that the ChatGPT, after the large data set training, it could actually identify the capital letters difference, and also all these symbols, they all matter. Like when you have a double star, it means strengthen or bold. bold symbol, right? So therefore, this is the suffix, right? Like it also instructs ChatGPT like the format of its answer is that in the explanation mention the column names that you use to get to the final answer, right? So these are providing basically instructions for ChatGPT to answer, like in what format. So after this, then basically you can or after you so then you can concatenate the prompt prefix as well as the question itself as well as the suffix then into one giant string, right? So these are the 3-part string concatenation. And then after this, then you can use this agent executor that you already constructed to run this prompt, this giant prompt, and you will get pretty much the result. And so this is what the brief workflow, how you would actually use LangChain to build a Q&A machine for tabular dataset. So the second problem, we mentioned that it will be actually how to use large language model to for prediction. Right, for classification problems. So in this case, it's not just a simple, search engine type of problem. So for this one, we would like to introduce a model called Tab LLM. So this is a paper that was a joint effort from University of Münster in Germany together with MIT CSAIL lab. So what they propose in their paper, you can see in this architecture is that the main contribution of this paper is the methods to serialize column features. So, and then they actually proposed 3 methods to serialize tabular data. So in really to serialize tabular data is really to convert column features into giant string of texts. So we can also look into details roughly like how these approaches are handling it, right? So you can see on the screen here, you have this table data, which has the column age, education level, and the gains and the income. So it's going to predict, right? So the first 3 column features are the X, are the input, are the predictors, and you want to predict their income level as an outcome, as your Y variable, right? So you have 4 training data set, right? Kind of, right? And then you want to predict the last rows outcome, income level. So let's look at, so firstly, the 3 different ways to convert these column features into text strings. So the first one is very straightforward. It's just that basically you put the column feature name first, right? So when you have age, then you just specify the value of that feature. So it will be a key value pair. So you will just, if the age is 42, the education is master, the gain is 594. So a very simple, straightforward, just listing the column features and their values and concatenate them into one text data. Yeah, so this way is to basically, this is one way to convert column features or table data into text data, right? So from Well, this table data basically is a combination of numerical data as well as categorical data, but it's just gonna like convert all of them into text data. So one sentence represents one record, one row, right, of data. The second one is more in the form of natural language, like how humans would probably describe this row of data. So it will be like, so it becomes a table to text kind of kind of way of, so it will be, this person is 42 years old, she has a master, the gain is $594. So it will be more using what human language would do, but instead of just listing like bullet points, the age is what the column features and then the values. The third way that they're converting the strings into text is actually using LLM models to convert each row of the column features into text, right? So it will be like the person is 42 years old and has a master's degree. So you can see the third method of LM is closer to the second method, which is table to text, right? So after you convert, so this is the very first step, is to convert the column features into text language, right? And then each of these texts then represents one row of data. So after this, they actually leverage another paper, which is called fine-tuning large language model using with the efficient parameters way. So in that paper, they claim that um, this fine tuning, but only on limited data, actually outperform the in context learning way. So, so as we mentioned at the beginning of this session, that now usually how people use ChatGPT is actually using in context learning without retraining or without fine tuning. But this paper is claiming that instead of like fine tuning the whole model, but you're only fine tuning a subset of parameters or added parameters of the large language model, but uh, keeping other part of the parameters frozen. So you're not really fine tuning the whole model, but only like a small part of the model. Then this way, it's actually the result is better than in context learning. So this paper is borrowing the idea of the other paper. So we would have another session actually going into more details about the other paper, actually how they're doing. So that paper's model name is called T-Few here. So it's basically called few shot learning, but parameter efficient, which means that you're not touching all of the parameters, but only like a small number of parameters. So after you convert the tabular column features into text, then you should firstly use one large language model. So just to have a note is that this model, this way of doing it is actually model agnostic, which means that regardless of what language model of you decide to use, you can use this framework. So either you use GPT-3 or you use GPT-4 or you use the Google's BART model, or you use any other. So this framework is actually model agnostic, right? So in this context, they're using a model called T0. T0 encoder decoder model. So this is the model that they chose. And for this model, we will also introduce these details in the coming session when we introduce the few shot parameter efficient fine-tuning method. Okay, so after you choose this model, then you will start using this T-few fine-tuning method to fine-tune this model. And yeah, so the entire paper name of this method of fine-tuning is called few shot parameter efficient fine-tuning. Is better and cheaper than in context learning, because we know that basically they claim that in context learning so far is actually the cost efficient way of using ChatGPT, is because usually these large language model is just way too big, and then for ordinary people like you and me will probably not have the resource to retrain the whole model. But in this paper, it's actually claiming that it's not only better, right, with this fine-tuning method, but it's actually even in fact cheaper than the in-context learning, right? So the note of this T-field fine-tuning is that it's actually not task specific, but it can still be applied to unseen new task. So why this point is important is because we know that one of the argument is that when you have this generic, right, the foundation model, language model, if you fine tune it, right, like what we did in transfer learning before, that what you would usually do is you have a general pre-trained model, but you have a downstream specific task, but you want to use this pre-trained model. What you would do is you actually fine-tune the model with your specific data for your specific problem. But the problem of this approach in the context of a large language model is that usually after you fine tune with your specific task, then you may actually make the large language model forget a lot of things. So therefore, it either becomes overfit, right, to your specific problem, right? Then therefore it cannot be generalized enough for unseen new task, right? So that is one problem of a fine-tuning um, foundation language model. So therefore, that's why people arguing using in context learning without any fine tuning. But in this paper, it's actually claiming that without fine tuning the entire model, but just fine tuning on some small set of parameters or added new parameters, it's actually not task specific. It's not like we are using, if we are to predict Titanic survivor rate, we are not really fine tuning the large language model specifically just to predict Titanic model. So it's not task specific. And then after you fine tune it, it can actually be applied to another unseen new task. So therefore, these are the survey of the two problems we explored today to how to use large language model to solve the tabular data. So we have 4 members so far in here. So if like any of you would like to raise any point or thoughts that you would like to have, feel free to speak up. Yeah.
Okay.
Yeah.
Is there anybody else that wants to?
Yeah,
comment?
I think I'm not sure we can see if other people are. I guess what we can do is to bring up the like just unmute yourself if you have any other questions that you would like to raise, or your any opinions or thoughts or questions, or like or what you're curious about, or what you would like to know more.
In regards to the paper about CSV, using prefix, suffix, and so on and so forth, as a data analyst, I'm quite interested in creating my own language model that basically is pre-trained on machine learning for
Right.
formulas.
Right.
So essentially, I would train it on data, and then input, output, and then like I'll train it on data. I'll give it the logic reasoning according to the Microsoft Dolphin Pro, like a white paper, and essentially it would then spit out the results accordingly. That white paper that you showed me about suffix, so on and so forth, maybe we could go further than that and train it on on CSV files as well as algorithms to then spit out valuable information.
For sure, yeah. I think it's definitely worth a try. Yeah, so I'm pretty sure like it's basically you just directly, instead of like load it into a pandas data frame, but like directly using CSV files or even probably SQL database. Yeah, that's a good
We
point.
just have to train it on a library of algorithms. Oh, this like what's the question? Oh, it sounds like you need this algorithm. Then feed it using that CSV file to feed the output, so on and so forth.
Oh, that's very interesting. Yeah, if you wanna try it out, and then we can have a session to talk about that. Any other opinions or
the topic you have of in context without context?
Yeah.
That's I can understand why there's more voices for in context. It's a lot cheaper to do than it was before. Before we had to make do with like 10K, like 5K context. There's the Claude AI came out with Claude 2, which has like 100K context. You can feed a book inside there.
Yeah, exactly. Yeah, exactly. So usually, so I guess for in context learning, you have either zero shot, so you don't either provide any training data, or you a few shots, so like a few examples to include it in the context. But then let's say that if you really have like, in this context, right, it's like to predict a supervised classification problem, then because usually in context learning, that when we were talking about, it's mostly like also in the problem of Q&A, right, to answer questions or to search engine or query. It's not really to output like a prediction. So let's say that if actually in this case, if you have like, say, like you said, like 100K training data set to predict a classification problem, then you included all of them into your context, then I'm pretty sure like OpenNet would charge you a lot in those tokens, right? So yeah, maybe this is a good point why the paper argued that maybe it's maybe in that context it would be cheaper in that way. But yeah, okay, I guess our session is from the Zoom then. Yeah, so we will